Welcome to the office. We want to take a look at permutations today. Remind ourselves of some of the things that we hopefully already know, but if we are not familiar with, that should be all right as well. All right, so permutations. See, if I wanted to give a quick definition of a permutation, I might say a permutation of a set of objects is simply a rearrangement of those objects. Nothing too crazy, right? I think that we're familiar with what a permutation is. So if we have for n, well, let's work with a specific number here, 4. I like this number. So for 4 objects, there are how many permutations? Well, we can decide that using the multiplication principle for counting. So I have an arrangement of 4 objects. So 1, 2, 3, 4. So I'm making 4 decisions. What thing am I placing in first, second, third, and fourth place? When I begin, I have 4 objects. Well, I can choose any one of the 4 objects to put there. For my second place, once I've chosen one of the objects, I have 3 options, then 2 options and 1 option, of course. And by the multiplication principle for counting, we say that there are 4 times 3 times 2 times 1, or 4 factorial ways to arrange the objects. So 4 factorial, in this case, 4 times 3 times 2 times 1. Yes, of course, as we have written here, that's 24 permutations. Okay, cool. Let's see here. A permutation of the objects in the set 1, 2, 3, 4 is, for example, we could rearrange it to be 2, 4, 1, 3. Just rearrange the objects in this way. When we recognize, so I've carefully written this so that way we can make an observation about the elements and their essentially, in this case, ascending order. So we have a particular arrangement that we start with, and then I'm rearranging it into this. And if we think of the locations, you could think of it as first location, second location, third location, fourth location, or again, just where they are to begin with. Then we can recognize that the first location is becoming 2. So 1 is being replaced with 2, 2 is being replaced with 4, 3 is being replaced with 1, and 4 is being replaced with 3. If we take this arrangement and make this replacement. Under that identification, right, 1 is becoming 2, 2 is becoming 4, 3 is becoming 1, and 4 is becoming 3. So this is a representation for a permutation. Okay, this is an example. I can rearrange the numbers 1, 2, 3, 4 by replacing 1 with 2, 2 with 4, 3 with 1, and 4 with 3. All right, so that's how they are being permuted. If I want to, I can also recognize this as a function, right? So here we have a nice, what looks like function notation, but if I really wanted to, I could give it a name and I could look at it as, let's see here, this is our domain and this is our range. Actually, we should call it the codomain. And we're taking the elements 1, 2, 3, 4 and replacing them with 2, 4, 1, 3. So I'm sending 1 to 2, 2 to 4, 3 to 1, and 4 to 3. But what we notice is that, of course, it's a function. There aren't 2 arrows coming out of any one of these numbers, but there are also no 2 arrows going into any of these numbers. So permutations are 1 to 1. Excellent. We also notice that everything is being pointed to over here. So permutations are 1 to 1 and onto. All right, so this is just some recollection of what a permutation is, a simple example, and then a way that we can view permutations, okay, as functions, which we then recognize as one-to-one and onto functions. All right. Again, our domain in this case, if we let A be the set of objects that we're permuting, f is a function from A to A, where f is one-to-one and onto. F is a permutation. Okay, excellent. So we want to call that good for now. Just a reminder of what we have for the idea of a permutation. I'll see you back in the office shortly for a continued discussion as we work towards groups of permutations.